Hello dear students, in this video we are going to learn Unit 3, Chapter 1, Laplace Transformation. So we are going to start with the definition of a Laplace transformation. Suppose you are having a function which I am denoting by f of t and it is defined for positive values for t. Then Laplace transformation of f of t is denoted by L of f of t and it is defined by integration from 0 to infinity e raised to minus st into f of t dt. So this is the formula for Laplace transformation of f of t. Now the limits is of t, variable t. We are integrating with respect to t, so the limits 0 to infinity are the limits of variable t. So you can see there's a variable s also present. So after integrating it, the final answer is going to contain s in it. That's why we denote the final answer by capital F of s. So here we are having the Laplace of f of t is equals to f of s. So you give input as f of t and you get output as f of s. And the transformation of f of t from f of s is given by Laplace, and the formula for calculating Laplace of f of t is this. Now, we are going to see the Laplace transformation of some standard functions. The Laplace transformation of some standard functions. The Laplace transformation of some standard functions. Alright, so here I am starting with the first function. So suppose your f of t is 1. So what is the Laplace transformation of 1? So first we are going to write down the definition of Laplace. So by definition of Laplace transformation we have L of f of t is equals to integration from 0 to infinity e raised to minus st f of t dt. Here my function f of t is 1. So in place of f of t I am going to put 1. Integration from 0 to infinity e raised to minus st f of t is 1 dt. Now we are going to integrate our e raised to minus st with respect to t. The integration of e raised to minus st is e raised to minus st and we are going to divide by the coefficient of t, which is minus s over here, and the limit is from 0 to infinity. So I can see that these are the limits of variable t. So minus 1 upon s is a constant that I will keep out, and I will put the limit in place of variable t. The first limit, upper limit we are going to put first. So e raised to minus s into infinity minus, put lower limit now, s into 0. Alright. Now next, what I'm going to get, it will become minus 1 upon s. Here it will become e raised to minus infinity and e raised to 0. Now we know that e raised to minus infinity can be written as 1 upon e raised to infinity. E raised to infinity will be a bigger number, so it is going to be 0. So minus 1 upon s, e raised to minus infinity is 0 and e raised to 0 is 1. So hence the Laplace transformation of 1 we got it as 1 upon s. So you can see in final answer s is present. That's why we denote the final answer by f of s. So here we got Laplace transformation of 1 as 1 upon s. Let us go to the second standard function. Second standard function. So let f of t is equals to e raised to at. Now we'll see what is the Laplace transformation of e raised to at. So again we are going to apply the definition of the Laplace transformation, which is integration from 0 to infinity e to the power minus st f of t dt. Now your f of t over here is e raised to at that I substituted in place of f of t. Now base is same, therefore power will get added. So next I am going to write integration from 0 to infinity e to the power minus st plus at. dt. Now I'm going to take out some common terms out. So I'll be taking minus outside and t also common. So I'll be left with s minus a inside. Now I'm going to integrate it. So integration of e raised to minus s minus I is going to be e raised to minus s minus a t the whole divided by minus of s minus a, and the limit is from 0 to infinity. Again, these are the limits of variable t. I'm going to take minus 1 upon s minus a out, and this will become minus s minus a into infinity minus e raised to minus a into 0. So remember, we always put the upper limit first. Next, so here it is minus 1 upon s minus a. Now here this factor should be positive. Otherwise, if this is also negative, this minus sign is already out. So minus and this minus will become plus. So I'll be having e raised to plus infinity, which will be a again undefined number. So that's why I want s minus a to be a positive value. That's why this condition is there. So it will become e raised to minus infinity, and this will become e raised to 0. So hence I'm getting minus 1 upon s minus a. Here it will become 0 and here it will become 1. So here is the answer 1 upon s minus a. Therefore, we got Laplace transformation of e raised to at as 1 upon s minus a, where s minus a should be greater than 0. So, the Laplace transformation of 1 we got 1 upon s, Laplace transformation of e raised to at we got it as 1 upon s minus a. So, let us see an example how we can use this in solving the problem of Laplace transformation. So, in place of a, you can be given Laplace transformation of e raised to 4t, so its answer will be 1 upon s minus 4. Alright. Now we can also be given e raised to half t. So its answer is going to be 1 upon s minus half. So these are the Laplace transformation of e raised to at. Now I'm giving you all to find out the Laplace transformation of e raised to minus at. Alright. So this is your task to find out the Laplace transformation of e raised to minus at. Now let us proceed ahead and find out the Laplace transformation of the fourth function. I did the first two and third I have given for homework, and the fourth one is let f of t is equals to sine 80. So what is the Laplace transformation of sine 80 that we are going to see? Now we already know that sine theta can be written in the form of e raised to I theta minus e raised to minus I theta upon 2i. So this formula I'm going to use to find out the Laplace transformation of sine 80. So in place of theta I'm having 80, so that I'm going to replace. So IAT minus e raised to minus IAT, the whole divided by 2i. Now I'm going to take Laplace on both the sides. So I'll be getting Laplace of sine 80 on the left hand side, and the right hand side 1 upon 2i is a constant that I will keep out, and I will find out Laplace of e raised to IAT minus e raised to minus IAT. So it is going to be 1 upon 2i, operate Laplace on each of the term. I will get Laplace of e raised to IAT minus Laplace of e raised to minus IAT. I already have told you in above that what is the Laplace transformation of e raised to at. So its answer is going to be 1 upon 2i. Its answer is going to be 1 upon s minus t's coefficient we are going to subtract, which is ia over here, and here it will become s plus ia. We are going to simplify it. 1 upon 2i, cross multiply it, s plus ia minus s plus ia, and in the denominator we are going to get this. Now this and this is getting cancelled. Here it is going to be 1 upon 2i into ia plus ia will become 2ia upon s square plus a square. So this 2i and 2i will get cancelled, and you'll be getting a upon s square plus a square. So therefore, we got Laplace transformation of sine 80 as a upon s square plus a square. So how can we use these thing in solving the problem on Laplace? So you'll be given question like this: find the Laplace transformation of sine 3. So using above formula, we can write it as 3 upon s square plus 3 square, which is 9. So this way we are going to use the Laplace transformation of sine 3t. So there's one more question for you all to find Laplace transformation of cos AT. Again, the similar fashion you have to do the way we found the Laplace transformation of sin AT, and its answer is going to be s upon s square plus a square. So in Laplace of sin AT we were having a upon s square plus a square, wherein in cos AT we are having s upon s square plus a square. That's the only difference. Now let us proceed to the next function, which is let f of t be a hyperbolic sine of at. So when you are having hyperbolic function, then what its Laplace transformation, that we are going to see. So again I'm going to use the Laplace transformation, that is the formula for hyperbolic sine theta, which is e raised to theta minus e raised to minus theta upon 2. So this formula I'm going to apply in finding the Laplace transformation of hyperbolic sine at. So hyperbolic sine at will become e raised to at minus e raised to minus at upon 2. Now take Laplace on both the sides. I'll get hyperbolic sine of at on the left hand side. 1 upon 2 is a constant, and operate Laplace on each of the term. So this is what I'm getting over here. Now we already know the formula of Laplace of e raised to at, or apply that. So s minus a, here it will become s plus a. Now do cross multiplication. So it will become s plus a minus s plus a, the whole divided by s square minus a square. So I can see this s is getting cancelled. You'll be getting 1 upon 2. In the numerator I will get 2a upon s square minus a square. So this 2 and 2 again will get cancelled, and we will be left with hyperbolic sine of at as a upon s square minus a square. So in Laplace transformation of sine at we are having a upon s square plus a square, wherein hyperbolic sine of at we are having a upon s square minus a square. That's the only difference. For example, Laplace transformation of hyperbolic sine Laplace transformation of hyperbolic sine of 4t is 4 upon s square minus 16. So this way we are going to use the formula for finding the Laplace transformation problem. Again, there's one more homework question. Find the Laplace transformation of hyperbolic cosine of at. This in similar fashion we are going to find out. So its answer is going to be s upon s square minus a square. You can cross verify it. Now let us go to the last function. Okay, I hope I have written the correct number. This was 6, this is 7, and this is 8. Suppose you are having a function f of t as t raised to n. Then what its Laplace transformation? So let us have look at the solution for finding the Laplace transformation of t raised to n. Alright. For that we are going to use the definition of a gamma function. So let us see how am I going to do that. So by definition of a gamma function, we have this already, all these things we are going to study under unit 5 also in detail. So as of now we will just understand the formula. The gamma of n plus 1 is equals to integration from 0 to infinity e raised to minus x into x raised to n minus 1 dx. So if we are having, okay wait, I've written something wrong. Alright, so gamma of n is equals to e raised to integration from 0 to infinity e raised to minus x, x raised to n minus 1. So when you're having n over here, the power of x is n minus 1. That's the only thing you have to remember. Okay, so let us do that. So we have to find out Laplace transformation of t raised to n. So by definition of Laplace transformation, we have Laplace transformation of f of t is integration from 0 to infinity e raised to minus st into f of t dt. Alright. Now here my f of t is t raised to n. So that I'll substitute over here. Now compare your this thing with this equation number 1. So here I'm having e's power as minus x. Here I'm having e to the power minus st. So here I want st to be x only. No s should be there. So I'm going to take the substitution. So put st is equals to x. So if your t is getting converted to x, then your t will become x upon s. Now differentiate it with respect to t. With respect to t, what I will get, s is a constant, keep it out. Derivative of t with respect to t is 1, and derivative of x with respect to t will become this, dx by dt. Therefore, dt will become dx upon s. So all these substitutions are done. Now also we want limits. So from where you will get the limits? So when the limits are 0 to infinity. So these are the limits of variable t. So when t is 0, the value of x is also, x is what? X is st. So it will also be 0. So when t is infinity, x is also infinity. So limits are unchanged. Now we are going to put it in equation number 2. So now we are going to put it in equation number 2. So let us put in that. So from 2, so Laplace transformation of t raised to n is equals to, integration is unchanged, limits are unchanged, so it will be 0 to infinity only. E raised to minus st. St I have taken as x, so it will become e raised to minus x. T is x upon s. The whole raised to n is going to come, and dt I am going to replace by dx by s. Alright. Now this is going to be integration from 0 to infinity e to the power minus x. It will become x to the power n upon s raised to n plus 1. So this is s raised to n, this is s, so s raised to n plus 1 it will become. Now again it will become integration s raised to n plus 1. I'm going to take it out. The limit is from this. And I know what is this. You can compare this with equation number 1. So it is gamma of n plus 1. Because here I'm having x power as n, so it will be gamma of n plus 1. So this is the formula of Laplace of t raised to n. Now remember, when your n is integer, where n can take any rational number, n is any rational number, but when n is integer, the gamma of n plus 1 becomes n factorial. So this formula you're going to use when n is a positive integer. So yeah, so we have covered all the formulae for finding the Laplace transformation of all the standard functions. So far let us have a summary. So when you are having a function f of t, we take its Laplace transformation and we get f of s. So when you are having a function 1, so its Laplace transformation was 1 upon s. When you are having function e raised to at, its Laplace transformation is 1 upon s minus a, where s minus a is greater than 0. When you are having e raised to minus at, its Laplace transformation is 1 upon s plus a, where s plus a should also be greater than 0. Sin at when you are having, so its Laplace transformation is a upon s square plus a square. Laplace transformation of cos at is s upon s square plus a square. Again I'm having f of t, Laplace transformation of f of t is f of s. When I'm having hyperbolic cosine of at, its Laplace transformation is a upon s square minus a square. Hyperbolic cosine of at is s upon s square minus a square. And t raised to n, we are having gamma of n plus 1 upon s raised to n plus 1, or you can have n factorial upon s raised to n plus 1 when n is an integer. So that's it. Thank you.